This one says to show that f of g of x is equal to 3 times 3x plus 1 times x plus 1, right? Now, what we're going to do is we're going to write the functions again. F of x is equal to x squared minus 1. I don't have I can't do the small 2 or the small 1, so I'll just use this sign to represent, an inverse function or a square. So it was x squared minus 1. And g of x, I know this well by now, is equal to 3x plus 2. Right? So you're saying to show that f of g of x is equal to 3 times 3x plus 1 times x plus 1, right? So what this is essentially saying is to replace the x in f of x with the function g of x. So instead of replacing it with a value, instead of replacing x in the function with a value, we're replacing x in a function with another function, right? This is called composite functions. Now, in composite functions, this is how you treat it, right? I'm gonna write like this first. G of x square minus 1. I'm gonna put this in bracket, another bracket. So this is what he's basically asking, right? So f of g of x f of g of x is equal to, again, put this in bracket, 3x plus 2 squared all that in squared minus 1, right? F of g of x. Now, how do you treat this now? Again, you're just using the maths that you learned so far. So you square in 3x plus 2. Alright, so it's going to be 3x plus 2 bracket. I'm going to use the asterisk sign here. Then 3x plus 2. Right? Minus 1. Alright, f of g of x now will equal to all of this. Now, to solve for 3x plus 2 times 3x plus 2 minus 1, we're going to do the multiplication first. And we're going to use the bird beak method. Bird beak method. Which is basically, we're going to multiply the first two terms of the bracket in the brackets. So the first term in the first bracket times the first term in the second bracket, which is 3x times 3x, which is going to be 9x squared. Now we're going to multiply the first term of the first bracket with the second term of the second bracket, which is 3x times 2. So it's going to be a positive number plus 6x. Right? And now we're going to multiply the second term of the first bracket with the first term of the second bracket. So it's going to be 2 times 3x. Again, another positive 6x. And it's going to be now the second term of the first bracket with the second term of the second bracket. 2 times 2, which is 4. Now, at this point, the multiplication is finished. So it's safe to add the -1 here. Okay. F of g of x is equal to, now what we're going to do is group like terms, right? So like terms are like 6x and 6x because they both have x, right? 9x squared doesn't have another like term because it's the only one that has x squared. Another like term is 4 and -1. They don't have x at all, like terms. So we're going to write back 9x squared because it doesn't have a like term. And then it's going to be plus 12x. 6x plus 6x is going to be 12x. And then this is going to be 4 minus 1, which is going to be a positive 3. Now, let's look back at the question. Minimize this. Question asks you to show that f of g of x is equal to, it's always so hard to say. F of g of x is equal to 3 times 3x plus 1 times x plus 1, right? Right. We're on track. It looks like we're on track. All we need to do now is factorize. So the first thing we're going to do is factor out a 3, right? A 3 is common between all of these coefficients in this equation. You can get a 3 out of a 9x squared, you can get a 3 out of a 12x, and of course you can get a 3 out of a 3, right? So we're going to factor out 3, then we're going to put a bracket. Now 3 into 9x squared is equal to, so 3 into 9x squared is going to be 9x squared divided by 3, which is going to be 3x squared. Plus 12x divided by 3 is going to be equal to 4x. And 3 divided by 3 is going to be equal to 1. At this point, we have the 3. We have the first term that we're looking for. We have a 3. So we're just going to continue. F of g of x. Always get to write this. Is equal to 3, bracket. Now, just looking at the answer that we're supposed to get at the top there, we're going to need to factor this equation again. So what we need to do now is we need to split up this second term, this 4x. We're going to split up this 4x into 3x plus 1x, or you could just say x. But I'll keep the 1x here because it will be easier to see. Right? Now this is a term 3x plus 1x. Now, this term, when multiplied, you're supposed to get the constant term. When the coefficients multiply, you're supposed to get the constant term. But because the coefficient of x squared is 3, you're supposed to multiply the coefficient of x squared, which is 3, times the constant, which is 1. So at this point in time, the constant should be 3, right? Now, 3 times 1 is 3, so it works out. It does work out. All right, so continue it. Since we have all of this, all we need to do now is factor out. What do you call this again? I don't remember the concept, what you call it. It is factorizing. Yeah, now you just need to factorize. Right? We're gonna group these terms. We're gonna use 3x squared and plus 3x. The common term of 3x squared and 3x is 3x. This is gonna be 3x plus 1 here. Because 3x into 3x squared is 3x, and 3x into 3x is just a 1. Gonna bracket this. And now, no, I'm getting ahead of myself here. We're gonna times this here. Gonna have 3x here. We're gonna bracket this here. So again, we're factorizing. So the common term between 3x squared and 3x is 3x. So we're gonna have 3x outside the bracket. Maybe I should have another bracket here. So 3x into 3x squared is gonna be 3x. Or is it gonna be x? Sorry, it's gonna be x. You're gonna leave x. And then 3x into 3, we're gonna leave 1. Right? Close that bracket there. This is gonna be a plus. Now, the common term in 1x plus 1 is gonna be a 1. 1x into 1, or 1x divided by 1 is gonna be x. And 1 divided by 1 is gonna be a 1. Right? Close the bracket. Now we see that we have, now we see, the answer being developed in here. We're going to have a 3. We're going to have a 3x plus 1. Plus 1. Then another bracket with x plus 1. Oops, I forgot the most important thing. g of x plus g of x equals, right? Man, that's a big one. How many marks is that? Oops.